So this is kind of to see what prior knowledge you already have, or it's kind of to see if you did your vocab last night, okay? You probably can't see these letters. I'm going to make them larger. For some reason, they got smaller. A, B, C, D, E, F. So after the test yesterday, you were given your angles vocab, and you were told for you and Google to figure out the answers to the terms. I wrote the definition, I gave you the picture, and you just needed to find the word. So we are starting a brand new unit today. It's obviously called the Angles unit. You can say bye-bye to segments a little bit. And in our warm-up, I was just seeing which ones you already knew from prior knowledge. Number 1, supplementary angles. That's going to be angles that add up to 180. It's going to be 2 angles. It's going to be a pair of angles that add up to 180. Number 2, acute angle. An acute angle is any angle that's greater than 0 and less than 90. So 87 is less than 90. Vertical angles right here. We're going to learn more about those next week. For now, you can just know what the picture looks like. Angle 1 and angle 2. Angle 1 and angle 2 are vertical angles. Angle bisector, I bet you can imagine what that means. It's just like a segment bisector. An angle bisector is a ray that divides an angle into 2 congruent angles, and that's what those arcs mean. Arcs are kind of like what a tick mark is to a segment. That's what an arc is to an angle. Complementary angles, angles that add to equal 90, a pair of angles that add to equal 90, and an obtuse angle, greater than 90 and less than 180. Okay, so get that vocab out, whether you did it last night or whether you didn't. These are the answers. So write these down if you didn't already get them. 12 vocab words that you should start to get to know over the weekend and throughout this unit. Okay, so new unit, new vocab. An angle. You do need to know that an angle is made up of 2 rays. It is made up of rays, not lines, not segments, but technically they're rays. So whether you can see it or not, there is an arrow on here. So it's made up of 2 rays that have a common endpoint, that have the same endpoint. Okay? There are different ways that we can name an angle. So remember, there were certain ways that we named a segment. Capital letter with a segment on top. There's a certain way that we name a point. Just 1 capital letter. So likewise, there's certain ways that we can name an angle. So this angle could be named multiple ways. I could call it angle 1 because there's a 1 in the interior of the angle. Notice how I put the angle symbol and then the number 1. Good. I could name it angle X, Y, Z. I could name it angle Z, Y, X. And what's the last thing I'm allowed to name this one? Yes, you got it. I could name it angle Y. Now, what do you notice about what's the same about number 2 and number 3? Y is in, well, what's the same? Yeah. Y is in the middle. So what's so special about Y? What is Y called? Starts with a V. It is the, come on, good. It is called the vertex. It's the vertex of the angle. So when you're naming it with 3 letters, the vertex always has to be named second. The vertex always has to be the middle letter. Notice how I put an angle symbol in front of all of those. If I had just written X, Y, Z, what would I have named? I wouldn't have named an angle. What would I have named from first week of school? Nope, not a line, a plane. So if you don't put any symbols in front of it, you've just named a plane, and I doubt you wanted to name a plane. Okay? Cool. Name angle 2 in as many ways possible. What's another name for angle CED? Don't type the answers yet. Okay, Megan said angle BEA. So another way to name angle 2 is angle BEA. And of course, you may reverse the order. Angle AEB. Now, what angle would I be naming if I just said angle E, which angle would I be talking about? So just be careful. In the last picture, we were allowed to name it angle Y. But in this picture, we're not allowed to name it angle E because there's 3 different angles at angle E. It's like in my 3rd period, if I call on Michael, and there's 3 Michaels, they won't know which kid I'm calling on. I have to use the last name too. So when there's more than one angle at a vertex, you're not allowed to name it using one letter. Okay? What's another name for angle CED? Which one is angle CED? Everybody type it. Which angle? Which number is angle CED? It's angle 4. Good. Okay, so when you're naming an angle, you just follow the letters C to E to D, and then you'll know which angle it's referring to. Okay. So, when I ask you to classify an angle, I'm not asking you what degree it is, I'm asking you kind of like what vocab word it is, how large it is based off of these 4 words. Now in this class, we're not going to go past 180. Those are called reflex angles, and so we're not going to study those. So all of our angles are going to be greater than 0 and less than 180. All of our angles. So if you solve a problem and you find that your angle is negative 30 degrees, you did something wrong. Just like segments don't have negative lengths, in this class, angles are not negative. Now, when you get to pre-cal and you take the angle and you rotate it under the x-axis, you might have negative angles, but we're not going to worry about that until pre-cal, okay? So, an acute angle, it's going to be greater than 0, and less than 90. A right angle, of course, is going to be exactly 90, nothing else. An obtuse angle is going to be greater than 180. Hello, Miss Stanton. Greater than 90 and less than 180. And of course, a straight angle will be exactly equal to 180. Okay? So we're not going to go below 0, we're not going to go above 180. All right, let's look at this really quick. No, you do not need to graph this. I just want you to think about this, okay? You found it. Okay. Consider ray BE. Consider ray BE with B00 and E50. So we're looking at this ray right here. What transformation or transformations to ray BE would result in a straight angle? So, good, Aaliyah. We could reflect the ray over the y-axis. We could reflect it over the y-axis and we would end up with a straight angle. What's the other way that I could create a straight angle out of that ray? By not reflecting. Very good, Aaliyah. You could rotate it 180 degrees. You could rotate it 180 degrees. All right. What transformation would result in a right angle? What could I do to ray BE to create a right angle? Rotate it counterclockwise 90 degrees. Good. What could I do to ray BE that would map ray BE to its original position? What would you do there? Good. That's what I wanted to hear. Aaliyah's killing y'all today. Rotate 360 degrees. We'll end up right where we started. So you will need that piece of information later in the unit when you're solving angles. Okay. Ha. A protractor. Get it? Like a tractor. Did you all bring protractors today, or do you have at least one you can share? I hope so. You may or may not have learned this in your previous math classes. Let me remind you how to use a protractor. So there's all different protractors out there. Let me grab a couple. There's different protractors, so you need to know how your protractor works, because this protractor is going to work a little bit different than the see-through protractor, okay? And they both work a little bit different than the protractor I have on the smartboard, okay? So, when you are measuring an angle, the vertex is very important. On this little protractor, this little diamond, you can't see that, that diamond has to be right on the vertex. In this protractor, like most protractors that you buy at the store, this hole, you need to be able to see the vertex through that hole. You need to be able to see the vertex, okay? And then the other important part is that right now, I cannot measure that angle. You need to make sure that one of the rays is at 0 degrees. One of the rays is at 0 degrees. And then you start at 0 and you just read. You start at 0. 10, 20, 30, 40. This one's a little past the halfway mark, so it might be like a 46-degree angle. It's between 40 and 50. You have to really squint to see that, but it's closer to the 50. Okay? Now, students have a little bit of trouble when the ray is rotated on you. You do not measure it in this manner. That's not really going to get you anywhere unless you want to do some subtracting. You could take the numbers and you could subtract them, but we're not going to do that when we have a protractor. So we're going to want to zero it out. We want to be right at the vertex. We want to make sure that our ray is right along the 0 line, and then we can measure. This is obviously an obtuse angle, so we're going to want to use the numbers that are greater than 90. So 10, 20, 30, 40, all the way over to 100, and it looks like 116 or 115. It's between 110 and 120, but it's a little bit closer to the 120. Okay, so in your notes, I want you to draw angle YXZ such that the measure, that's what that M means, you're going to see that a lot, such that the measure of angle YXZ is 53. So, start by drawing a ray on your paper. Draw a ray XY. Draw a ray on your paper. Get your protractor out. Find 53 degrees. 1, 2, 3. Put a dot. Ooh, my dot's not working. Put a dot there. Then you can move your protractor out of the way. And with a ruler, not with a straight edge, not by freehand, with a ruler, connect the end point to the little dot that you made at the 53-degree symbol. This is just in your notes. So don't worry, in your homework tonight, you're going to get a lot of practice with measuring angles and creating angles, okay? Let me tell you one thing in your homework, because as I was keying it, I noticed some things. In your homework, if your angle is this big, and your protractor is this big, don't you dare just eyeball where that ray is going to fall. No, no, no. Take a ruler, take a straight edge, and you need to extend your angle. Make it long enough so that it goes through one of the numbers on your protractor. Okay, so that's really important because on the homework tonight, some of those angles are pretty tiny. Okay? All right, we're going to do the next phase of the lesson, which is angle constructions. This time, for this part, you do have a handout. Angle constructions. Okay, so today we're going to learn two things. We're going to learn how to copy an angle, and we're going to learn how to bisect an angle. Hopefully that sounds familiar because we learned how to copy a segment and we learned how to bisect a segment. I'm going to show you on the board, and you're not going to do it while I'm doing it. You're just going to watch. But then I'm going to take you to Math Open Reference, to that website that I always send my students to, and I'm going to play it over and over again because this one does have more steps than just copying a segment, okay? So I am going to show you how to copy an angle. First, you put your needle, you put your point on the vertex. That's how you're going to start all of your angle constructions. Put the angle on the vertex. Then you can open your compass however much you want. It doesn't matter how much you open it. You don't want it to be too tiny or too large to where it's hard to work with. Open your compass to what they call an arbitrary amount, arbitrary setting, and you make an arc. Of course, you keep that same exact compass setting, and you go down to the ray that's given to you, and you make an identical arc. So that's step one. Don't do it yet. Make an arc, make an arc. Okay. Step two, this is how you're going to tell how big your angle actually opens. You're kind of measuring it with a compass, although you don't call it measuring. So the next thing you're going to do is put your needle and your pencil, come on, yep, that's close enough. Put your needle and your pencil in the two places where the arc hit the angle. Needle in one spot, pencil in the other. Okay, then you go down to your picture and you put the needle, my alignment's off, sorry. You put the needle where the arc intersects the ray. You don't do what Miss Stanton just did. There you go. And you make, oh goodness, when your alignments are off, it's hard to show. You make an arc right there. Then with your straight edge only, you draw a ray through the intersection of those two arcs. If that was horrible demonstration for you, watch this next thing. All right, let's watch this one instead. I'm just going to play this over and over so you can watch it as many times as you need. You open your compass. You make an arc. You go over and make the same exact arc. You put your needle on one point and your compass on the other. You go over, make that second little arc that intersects, and then connect the dots. Play it again. Go ahead and try the first one on your worksheet, but watch this demonstration as many times as you need to. Yeah, they do make it look so simple, don't they? So this website's called Math Open Reference. If you wanna bookmark that at home, they do a great job with constructions. It does not matter how much you open it, Aaliyah. Good question. It does not. It's in what we call an arbitrary amount. But you just need to keep that same compass setting when you go down to make that first arc on your ray. So you're trying number 1, and now you're trying number 2. When you copy the angle, I want you to measure those angles and make sure that you copy them correctly. And we're going to write the measure of the angles in there to make sure you know how to measure as well. For angle A, are you getting about 70? And angle B about 35? When you measure things and I grade it, I always give you a cushion of about 2 degrees. Maybe even 3 degrees if I'm feeling generous. So if the answer is 68 and you put 70, you would still get it right, okay? You know, when we were doing segments and we were, oh, never mind. We'll get to bisecting an angle in a minute. We'll get to how we can bisect an angle by folding it, and we'll talk about that in a minute. All right, let's do bisecting an angle. Believe it or not, this one is actually easier than copying an angle, bisecting an angle, okay? So, watch me first, and then I'll let Math Open Reference do the rest of it. So, to bisect an angle, you're going to open your compass an arbitrary amount. It does not matter how much you open your compass. You are going to make an arc. Then you're going to make 2 additional arcs. You're going to put your needle where the arc intersected your ray. And then you're going to put your needle where the arc intersected the ray in the other spot. And boom, you just made 3 arcs. You didn't change your compass setting the whole time. You made 3 arcs, and you connect those dots. And yours will look better than mine because you're going to use a straight edge. And Miss Tanton did obviously not use a straight edge. So let's watch them do it here. Here we go. Here's the right one. So if you don't have the paper, you can just draw an angle in your notes. You open your compass. Ooh, he's going slow today. Oh my goodness. The connection must be bad. It's going really slow. Okay, last try. Let's see if we can watch them do it this time. This is much better. So you notice you make an arc, put the needle where the intersection is, put the needle where the intersection is, and connect the end point to the intersection. Notice how they put an arc here and an arc here to show that they're congruent. They put a tick mark on their arcs. We don't usually put little tick marks on our arcs. We just put an arc. Okay? It is easy, isn't it? Okay. So that was the only lesson today. So the goals of today was to be able to name an angle, to be able to measure an angle, and to be able to construct a copy of an angle, and to bisect an angle. So in your homework tonight, called Angles and Constructions, those are the only things that you'll need to do. Yes, that's the homework. What we didn't talk about, I promised we'd talk about it real quick, what we didn't talk about was we constructed an angle bisector with a compass. How could you construct an angle bisector? By folding your paper. Or how could you check that your angle bisector was correct? By folding your paper. So you would need to take the paper, hold it up to the light, and you would need to fold it to where one of the rays exactly falls on the other ray. So you're pinching it at the vertex, and you're pinching it to where your rays line up perfectly. And once you do that, if your rays line up perfectly and you crease your paper, you will have constructed a crease, an angle bisector. You can't see my crease, but it's there. Okay? I was asked if you need to finish this page. You will want to finish this page before next Tuesday, because that's when your assessment is. So whether you do it this weekend or whether you want to do it Monday night to have it fresh on your mind, that's up to you. But you will want to do all 7 of these before next Tuesday, because this is what your assessment is over. You're going to be making a picture, and you're going to be using a ruler and a compass to make a whole picture. And it'll give you step-by-step instructions, and it'll be pretty. It's a fun assessment.